Our senior design project was developing a pellet fed lab scale 3D printer. Our lab scale 3D printer differs from traditional lab scale 3D printers, in which our 3D printer utilizes plastic pellets instead of plastic filaments as 3D printed material. Pellet-fed lab-scale 3D printers can be more desirable than filament-fed lab-scale 3D printers because of the cost difference between plastic pellets being much cheaper than plastic filament, which is very desirable for businesses which do a lot of 3D printing.
When we initially received the 3D printer, the gantry was functional, containing all minimum necessary components for proper zeroing and allowed for bed leveling. It could interface with the G-code in software, and the heat sink appeared to keep the motor cool enough during long periods of heating. The pellets would get stuck halfway down the barrel and would not liquefy, however. The extruder motor was not strong enough to push the semi-solid pellets through the extruder. The screw was not an ideal design, and the heating was insufficient at parts.
We started testing by installing the larger, higher torque stepper motor and raising the heater temperature to about 260 degrees Celsius instead of the 185 recommended by previous team. After identifying the coil heater as too inconsistent, we removed it along with the heatsink and installed the ceramic block heaters that the first team used instead. The extruder was then painstakingly primed over the course of several hours. But once this was done, a repeatable initialization procedure was found that made the barrel and screw burn-off unnecessary between prints. From here, our team ran prints to find optimum layer heights, print speeds, and explored the effects of screw retraction.
In its current state, the printer is able to consistently extrude PLA pellets at a maximum speed of 20 millimeters per second before belt slippage occurs. Printing is performed by feeding the pellets into a barrel where a belt-driven extruder screw moves the pellets down the barrel. Once far enough down the barrel, pellets are melted by a ceramic heater, which is run at 280 degrees Celsius. The melted PLA is then extruded through a fine tip onto the printing bed. The printing is currently controlled through Pronterface, which has worked better than the other available printing softwares. Future work on the printer should be geared towards fixing electrical issues and fine-tuning the print software to optimize printing quality.